We have to do this right because I am the administrative agent for Mississippi. John is one for Louisiana. And you also notice that I'm here by myself. I am not the, if you came here to see the other guy, Dr. Dennis Delaney, he had an unavoidable conflict come up. He has to be in Alabama all day long today or tomorrow, one or the other. So that's the bad news. The good news is, you still listen to me for that time. I'm glad to see I didn't have anybody on it. But anyway, if you came to hear him and you keep waiting for us to switch, there's not going to be a switch. So again, I thank you for coming. We've had some technical challenges. I think we're there. Not everybody reads all the small print. What I want to talk about today, for some of us more seasoned people, is something that might seem like it's old hat. And it is old hat. Does the time of year we take a soil sample make any difference? And I have been at Mississippi State for 20 years and 2 months. I have been involved in soil fertility work for 10 years, as started in March of '86, so that's knocking on 31 years. And this is one of the oldest things in soil fertility extension that we have. If you take soil samples in February, March, take your next set in a February, March. If you take your samples in the fall, most of the Mississippi row crop area, they have extensive soil sampling programs which happen after harvest in the fall. Well, why do we say that? Again, I've been in this business 31 years. This is one of the oldest questions we have dealt with to this time. And we got to a point where we had some strategic requirements. We had some strategic issues. When this project came up, Ted Peck, the late Ted Peck, ran the University of Illinois soil testing lab for over 30 years. And every 3 weeks for that 30 years, he took soil samples from 2 fields on the edge of Champaign, Illinois. And when he retired, somebody tossed all the data except for about 6 or 7 years. And they had been trying desperately to find it. They don't know where to toss it, but they had decided it's probably in a landfill. So that is what we're dealing with. We've had a massive retirement in soil fertility in the 80s, 90s, and 2000s, that where we lost some of our corporate memory. We had it happen in Mississippi State because a lot of the work that we provide was based on work of Dr. J.D. Lancaster, who was one of the best scientists probably ever to operate in this part of the world, if not the whole world. But he didn't publish extensively, but the work he did was impeccable in the world of soil fertility, calibration, and correlation. We cannot find anything wrong with it. And that is the basis for the recommendations we have made for our extension lab all these many years. But when he retired, Experiment Station said, we've already learned all that. We don't need to continue doing it. Well, time passed. Yes, we did need to continue doing it. And some universities are doing some things. Louisiana, LSU has had Brenda working for a number of years. Bobby Golden is working for us in row crops in the Delta, trying to address this issue. Georgia keeps hiring people and they keep working a year, then they go do something else. So I don't know where they are at the current moment. But it is an important issue in the South and in the nation. We're just looking at our basic soil fertility work. And I'm going to start here at the beginning. Soil happens. I stole this concept from the University of British Columbia on the internet for another presentation a few weeks ago. But I like it because it presents everything that you get the first 3 weeks of soils class in one slide. And it gives you an analogy of what's happening. We have five basic soil factors. You know that climate, organisms, from microscopic to human to bigger, working on the situation. The topography, how the land lays, whether it faces the sun or faces away from the sun. It's a big deal in soil formation. Parent material, what you start with. In the Delta, in Mississippi, we start with alluvial soils. That means they used to be elsewhere. And they were laid down by water action in the old channels of the Mississippi River. And that gives us certain challenges in soil management and soil fertility. Land leveling has changed it a little bit. Time. All these things take time. So we have a setting for these things to happen. And then things happen during the course. We have a theater of the soil, of the landscape. Then things happen that's actually taking place in the play. We got additions, we got subtractions, we got transformations, all these wonderful things going on. Things moving from point A to point B. Transfer is part of where we get our delta salt from, because they all used to be upriver. So that's action. Then we get to a point in time where we have the soil that we see today. And when we do soil sampling, we're taking a snapshot of this snapshot at one point in time. And that's the important part of why we want to look at the timeliness of soil sampling, the snapshot. Stow that elsewhere. Now, farming is a business. And when we do soil fertility, we make fertility recommendations. I have been presenting this for many years, Joe. You may have seen this, Chris. But times have changed since I started looking at this thing. This is the price of fertilizer on an elemental basis. Price of nitrogen per pound, price of potash per pound, price of phosphate per pound. The flat blue line is the price of potash per pound annually from 96 to 2004, based upon the survey that the Economic Research Service used to do every April and then published in RAC. This is from the Mid-South. And I will say, I just recently discovered they quit doing it after 2014, to my aggravation. They didn't ask me. But you can see that my friends in the fertilizer business said the price of potash was flat for a long time, 14 cents a pound. It varied between 13.6 and 14.2. That's pretty flat. The price of phosphate had a little more bounce, but again, off the screen. Okay, what we're talking about, price of phosphate about a quarter a pound, essentially forever. Nitrogen, you see, is a little more volatile. It changes with time. But what are these times? 2001, we had a societal event happen in 2001. It was a national event, international event. It created volatility in the market. At luncheon today, I saw some more evidence of this. 2004, we start to see a hint of things happening. What happened in 2004? 4 hurricanes hit Florida. That's a long time ago, because in Louisiana, Mississippi, thinking hurricanes started in 2005, August 29th with Katrina. We had those 4 hurricanes, Florida, 2004, that disrupted natural gas production in the Gulf of Mexico, disrupted mining in Florida, phosphate mining, potash mining. This is some major disruptions in 2004. Then, as we saw today, we get to the collapse period, the financial turmoil, what have you, 07, 08. Again, these prices are smoothed because they're an April snapshot of the fertilizer prices. 2008, 2009, see potash is up to 74 cents a pound. If you remember back that far, you know that that is conservative, because it got up to about $1 and a dime a pound in the fall. And it was back down to this when this survey came in April. So now we went from flat lines to spaghetti. It's a little more volatile. There's been some stabilization. Things that he talked about today, the BRICS concept, when the fertilizer markets first went awry, I saw a lot of blame to China and India, because they're wanting to boost their protein in their diet, which means they have to have corn, and they have to have soybeans, and then to have corn, you get nitrogen fertilizer. And they were soaking up the supply. Put it all together, you see, we were fairly calm till that period of time. So again, going back to why this issue, I've given the sermon about from a soil fertility science standpoint, and now I'm going to talk a little bit about perception out in the real world about this. How many of you have heard soybeans don't need fertilizer? How many of you have seen that farmers do not fertilize soybeans? Well, survey says that back when they did it, and this is Mississippi only, Phosphates applied to 17% of the soybean acreages in the state of Mississippi. Potash, sorry about that, folks, and to about a fifth of the acre. Now, if you look at the rates they apply, it looks dangerously close to 100 pounds of diammonium phosphate is put on every year. They say 2050, but then you know it's probably 1846 old. So, but we are fertilizing. The native fertilizer. This is from our soil testing lab in Starkville. We do not get anywhere near all of the totality of soil samples that are taken within the state of Mississippi. We get the samples that people decide to utilize our lab. There are good, viable commercial options operating in the state. But the samples that we do get, we just look at the delta, total soybean recommendations. The fourth of them for phosphate are medium or below. Sorry about that. I don't even know if I'm touching. And about 10 or 11% of them are medium or low in potash. Why is this a big deal? Why do we care if it's medium or low? Okay, go back to Dr. Lancaster's work. If you look into our current recommendations, we have what are called indices based upon Dr. Lancaster's instructions that he developed. It's a mixture of weak organic acids for the most part, which, if you're following the soil health issue, will look suspiciously like what the Haney soil test looks like with weak organic acids as extracted. For phosphorus, 0 to 18 pounds to the acre is considered very low. And actually, anything below 72 pounds to the acre is medium or low or very high. 73 to 144 is high, greater than 144 pounds is very high. For potash, Dr. Lancaster and his graduate students figured out to use cation exchange capacity as a proxy for soil texture because the potassium information differs by the texture. And the CEC, a low CEC is going to indicate more sand in the soil. Higher CEC is going to indicate more clay in the soil. So they develop these ranges. And our recommendations are based upon these. With potash, of course, you know it's more complicated. But I will tell you, this is from our nutrient management book. For soil test P, it says use table 2, that's table 2. For soil test K, use table 3B, that's 3B. But down here you see medium, low, and very low. We make recommendations. Go back to those indices. That's not a lot of differentiation on phosphorus between. So a 35 pounds to the acre for phosphorus is going to trigger a recommendation where 73 pounds to the acre.
Is that P or P205?
Should be P205. That's one of the errors we got corrected below. So we triggered a recommendation, and the recommendations for increments of potash, P205, it does right in this one. P205, 30 pounds to the acre, 30, 60, and 120. And for K2O, it's in increments of 60, 60, 60, 120. I will note, land-grant universities, for the most part, use a very conservative philosophy for making fertilizer recommendations compared to some alternative recommendations. This phosphorus recommendation in the very low is actually a generous one. This is kind of a buildup in the very low using us. And we're kind of an outlier in the land-grant university. It's one of the things when Bobby first came on board with us. We know we have a buildup in there. Yes, we do. Dr. Lancaster said we need it. We don't argue with Dr. Lancaster. So, how much does it cost to do it at that rate? Put down 30 pounds of P205 is the blue line, looking at $20 an acre. Again, this goes up to 2014. They didn't ask me if they needed to stop the survey, but to keep it consistent, I had to stop it. The potash is going to cost about $50 to $60 an acre. So, if you're in that first category, in the medium, it's going to cost you what? $70, $80 to follow our recommendation, if you choose to follow our recommendation. legally. Remember, I said we recommend it. That doesn't mean you have to do it. But this is what we say. We think there is a pretty good probability of response if you put this fertilizer on. You have the opportunity to not put it on. And Bobby is looking into further aspects of this in the modern world. Because again, this is kind of dated material. We have to be updated. And one thing we need to update is the simple economics of it. Again, the old recommendation, sample at the same time next year. Not many of the folks here are probably going to be concerned about lime, pH and lime issues. But this is something we have to deal with statewide. And lime is not cheap in Mississippi. You get a 2 ton to the acre recommendation, you producer, you consultant, so you put down 2 tons. That is a significant investment. Again, we talked to 70, 80 bucks for the fertilizer. The lime is going to be that much more, which is still, me being a native of West Kentucky who grew up within sight of a lime pit, is still hard for me to comprehend. We paid $4 a ton for it when I was coming up. And the haul was 2.5 miles. So I come here, we're talking some exorbitant lime costs in parts of the state of Mississippi because it has to be transported in. They don't have lime pits, hard lime pits within sight. And again, another factor in our modern world, we have this information. We've drawn these wonderful soil fertility maps. I know some of you are in the business though. We need more information. We're going to have more information. So, and some folks, I have seen people advocating soil tests like once a week during growing season. So, I don't understand this. So, but again, and also, another consideration is the good old insurance concept. It's only 50 or 80 bucks a dig. When I deal with snake oil set, we have one in particular. Their application cost was $25 an acre a couple of years ago. And the stuff didn't work. We had tried it in field trial after field trial. It did not work at all. So at the same time, at our house, we had to buy a new refrigerator. And I found out that modern refrigerators can be expensive. So I looked at it this way. You can buy a really upper crust fertilizer for $2,500 bucks. And if you buy $25 an acre worth of stuff for 100 acres of corn, you put it out and you spend $2,500, you have essentially just bought them a new refrigerator and cost yourself a refrigerator. That's gets into real money after a while. So buying things you don't need, it's not a good thing. I started off farming the first few years of my career, and I'm real sensitive to this money issue. So, but get back to the soil sampling. Where's the data? We know that in Illinois, it's not available. We know that there were other old folks who did it. The pillars of the soil testing community. Ted Peck was a great person in the world of soil testing. Late Ted Peck. So we decided we would look at it. Not everybody agreed with me when I first proposed this. I said, this is something simple we can do. This can be applicable to every grower in the state of Mississippi, whether they grow soybeans or not. The Soybean Promotion Board generously helped fund it for the first 3 years that we did it. We ended up with 8 locations across the state. We started with 9, but we lost the site on the sand in George County after the first year, darn it. And also, it was not on an experiment station, so we had no control. We do a standard soil sample monthly, about the first of the month. If I wasn't here, I might be out sampling today, but we have some other operational issues of our soil testing lab right now, so I don't know when I'm going to take them for February. 70 months so far. Started in April 6 years ago. It's a simple little thing. We do a routine analysis. I take the sample to the lab when Dr. Krause was there. He took a subsample, did a moisture check on it. We ran PK. What else he does? Calcium, magnesium, and I did recording cation exchange capacity and pH. Which shows some pH data. I remember to do that. So it's simple. All we're doing is once a month, a routine analysis. And And I will say, well, I'll bring it up later. Where did we do it? We did it at these 8 experiment station locations. Start down here, the Loring soil is on the Brown Elm experiment station, a little bit south of Jackson. I think it's in Hinds County. Brooksville is the Black Belt experiment station in Brooksville, appropriately enough. It's one of those interesting black belt soils. It's 20-inch black soil on top of white chalk. We'll see it's quite sticky when it's wet. Marietta and Savannah are in Starkville. North Farm, South Farm, as you may know if you're familiar with Mississippi State University. Marietta is North Farm down in the bottoms. Savannah is the South Farm. It's a red soil up on the hill. I like having Savannah in this study because, as you know, I spent a lot of time in the last few years dealing with chicken manure in south central Mississippi, and that is a major soil type down there. And everything I learned about Savannah I like. Atwood and, well, let's go over to Delta first. I call it Bosket A and B. This sample is in one of Dr. Eberhard's studies on the Delta Research and Extension Centers. I keep them separated for a reason because they're 16 rows apart, but they have a little difference. It's just for fun, for me to aggravate Wayne's about. Atwood and Faulkner. See that arrow? It specifically points to that line between two soil types, two general soil types in the state of Mississippi. The Pontotoc Ridge experiment station straddles Highway 15 just north of the Pontotoc County line, just barely into Pontotoc. And there's one soil type on the east side of Highway 15, one soil type on the west side of Highway 15. Very different soils. They're a mile apart. So it gives us an opportunity for a lot of good soil work up there because we have this juxtaposition so close in the landscape at Pontotoc. So, the Atwood, Faulkner, the Pontotoc, Bosket A and B. One of my favorite soils terms, Bosket would be considered an ice cream soil. If you're out there, the right time of year, right moisture conditions, it is truly an ice cream soil. So, you see that the ice cream soil, it has next to no organic matter in it. 0.7, 0.8, 0.7 actually for both of them CEC. But see, one's a loamy sand, the other one's a sandy loam. We did this in the lab, so I keep them separate. Sandy loam, loamy sand. Dr. Krause did the work. But so we have a little bit of range of pHs. This are the phosphorus levels with the indices, medium, high, very high. See, we had some pretty fertile soils at the beginning, soil test K. Actually, we have one site, the Atwood was the only one that the potassium that we kicked in a recommendation on. But again, this is for the long haul. We want to see what happens. This was simply April 1, 6 years ago. Yeah, I mentioned most of these people. Dr. Krause, he just recently retired 2 weeks ago. He's the manager of the soil testing lab. Dr. Eberhard at Delta Station in Stoneville. Dr. Raccoon runs things for us at the Brown Lane Experiment Station. Dr. Schenkel runs things at the Pontotoc Ridge, Flatwoods Branch Experiment Station. And actually, he's got 2 really good people that take the samples. Mark gets all prepared. I started off as one of those people who took the samples, so I always wanted to. So what's happened so far? 70 months of data collection. We had a couple blips. We lost one original site. We lost 2 months on the Savannah last summer. But we knew it was coming, and it finally happened. They built a road in our field. Not any little road. They built a superhighway in our field that connects South Starkville to campus. And where we were taking the samples is now a gravel road next to the superhighway, so we couldn't get to it for 2 or 3 months. Now we can get to it, but we have shifted down the slope a few feet. I don't know of any other experiment that I'm aware of that's had to have a pause due to building a superhighway in the middle of the field. So that happened to us. We lost George County site. Promotion board gave us funding. It's not an expensive project. It's time and travel and a little bit of lab work, which has been covered by my extension budget since then. And I also learned time series analysis. I am a soil fertility person. I don't know anything when I start about time series analysis, but I did enough work on homework on this to learn one basic fact. Anything with 30 data points or less is not good. You need at least 30 data points. This comes from the business world before you have any real ability to distinguish a trend. So we're at 70 or 66 to 70 on most of all these sites. And we're starting to get some results that I have confidence in. One of my esteemed soil science colleagues asked me last week when I was preparing, he said, did you get any significant differences? I said, Jack, we're not looking for significant differences, we're looking for trends. Well, he's a soil fertility person anyway about time series, but I digress. And I did learn that SAS, the statistical program, screws over people. The only thing that was different was added a few more months of data, and the file became unreadable in SAS. And it took me a whole day to get the right line in, to get the damn stats right, because they changed the input method for an Excel file. The people in North Carolina are sadists. They don't understand it. I don't have a day to devote to figuring out one line of code, but I had to. I have presented this as posters of two National Agronomy Soils meetings, American Society of Agronomy, Soil Science, my Society of American meeting. And I talk about the other people that are concerned about this thing. I have had more interest in this project than anything else I have worked on in over 30 years from my colleagues in soil science extension. More interest. People looking in the program, coming to the poster to see what I learned. One of them was one of Ted Peck's former graduate students that had been trying to find the data. He worked with Ted for a number of years. He's very interested. So David's an old guy. The last time I presented, the first person showed up with a program in the hand was a very young faculty member of the University of Idaho, who said that this was something she was intensely interested in. So this is something I feel confident in from a science point of view. Not that I needed support from the people, but I had to do a lot of talking into it amongst my colleagues that this was something to do. Not people who necessarily have done this for a while. So what we found some screw lines, and I know y'all can't see anything from back there. I'll tell you what we have. This first graph up here is a soil test value from Bosque A. That's the loamy sand version of the Duo and the Delta, also known as plot 105 in the rotation stage. Long-term rotation stage, the century stage. Wayne is going to carry it on for 100 years. I don't think that he is going to be around for 100 years, but that's the plan. It will be continued. And this is a corn soybean rotation within the rotation study. So this is 3 years corn, 3 years soybean. And that doesn't play much into what I presented here, but it's made a significant difference in the moisture, particularly in the late summer and fall sampling, because the corn is gone a long time before the soybeans are. The soybeans are still pumping water out in the late summer, and the corn stalks are dying, and the only thing that's growing is stuff that you really don't want growing. So anyway, we started here, 89 pounds to the acre. It'd be about there, and we've had a bounce. Turn around and look at the variation in that from the, this is a variation from the original 89 pounds. And you get this very similar looking bounce, some differences. With soil test potassium, we started 298. Strangely on this, the variation looks extremely just like the raw data bag. pH values, we started at 6.8, somewhere up here, and we went down, 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 and then we got a lot of bounce. And we have some outlier data. I've gone back and looked, and looked, and looked. And it's not entry data. It is a real data point, but we'll have to see if it keeps in it as we continue on in the analysis of it. But again, this is raw data. We're looking for what? Not significant differences. We're looking for trends. This is the trend analysis from the time series analysis. And you see, we did go down. We've got the bounce. And it's almost a flat line for the soil test phosphorus. Soil test potassium has gone down a little bit. I want to get Wayne about his potassium fertility program. The pH, we started at 6.8, 6.9, went down, and it's pretty stable. This is where the interpretation comes in, why you do the sampling same time every year. See the red arrows? I didn't do this dramatically, but I'm trying to point to the fall season. Look at the pH in the fall. pHs are almost always lower in the fall. And the company lime recommendation is always higher in the fall if one is true. Why? We have the effect of fertilizer salts that may have been applied that weren't utilized by the plants. We have a salt effect there. We also have the effect of the growing plants there. And we're learning more and more about the rhizosphere chemistry that happens in growing plants. But one thing they do is they pump out moisture, and it's usually drier in the fall. See, so it's going, you don't have 2009 up there. 2009, we had a very wet fall, but we didn't have a project ongoing then. But then we didn't have as many hurricanes during the course of this study so far, across our fingers and all that. Now, that's the Delta location, and just for fun, because I like the red soil, the Savannah soil, and actually this is only about 1.5 miles from my house in Crow Flies, so see what's going on. Soil test phosphorus, we started 190 pounds there. That's really high. That's very high. We bounced up a little bit, and we've leveled off until recently. Here it started to nosedive. Potassium, it's got this November 2013, things went awry with the samples. And the pH, the same thing. Once in a while, again, usually in this dry part of the year, we'll kick in a lime recommendation on the Savannah site. The Savannah site is not row crop. It is a beef unit field. It's got Bermuda grass and has annual ryegrass planted in it most years. And I think this pH rise can be attributed partially to the road construction, because you just had a whole lot of limestone rock put down next to the field for the superhighway and for the farm access road. And we've seen this before. I did some sampling, and I got one of Dr. Varco's plots on North Farm that was adjacent to a road. Right adjacent to the road, the pH was 7.6. And in the plot area, it was like 6.2, 6.3, 6.4. It's effective liming from the dust as it goes down. You got a question, Joe, or you just...
Why do you think you had the spike in potassium
in that one? Your guess is as good as mine. I went back and looked at the raw data, the data sheet, and it's just there to aggravate me, I think. I bring Dr. Krause, he was hard. He ran the sample, so. Anyway, so the summation of monthly soil testing is, it varies during the year. We know this. Weather, presence or the absence of growing plants. We have sampling testing variability, sampled same time next year. Recommendation is still correct. The bounce is expected. It's part of the natural system. Get used to it. But we have some sort of justification of what we've been saying for all these years. And I have got something to tell all these people. It's not necessarily row crop producers, Delta producers, but in the other part of the state, they spend a lot of money on lime. They put it on January, February, March, and then they want to know if it worked. Well, then they sample in September and it hadn't rained since the middle of July, then their pHs have tanked or not moved. So they think they got cruddy lime. No, you've got a natural system that has a lot going on. So let's just shift to the soil focus. This is what you get from the other guy having a conflict. And you got to have a soil and water content. We have almost 300 different soils in the state of Mississippi. They all are doing their thing. They're operating in the theater, on the landscape, all these factors coming into play. And we can do all kinds of wonderful laboratory stuff now on the soil. And they can have effect. This is from Washington County, from photos by Rachel, who worked as a soil scientist for NRCS. This is a Sharkey. It's a map to Sharkey in Washington County. The dam is not in here. I think the only difference on the landscape between these two, this is in the forested side of the turn row, and that's out in the field. So when we crop the field, we work it, we do change things there. Some of the things that we can check in soils, again, we have a wonderful ability to check a lot of things. There are some biological components up there. There's some talks here this week looking at soil health and the biological components there. It's a very complicated subject. We like soil health, but getting a handle on how to assess it is not an easy process. We've long looked at soil organic matter, row crop samples in Mississippi. We've been giving you an organic matter number for years. But we also have all these other things we can look at that are going to be, that are decent indicators of a functioning, working soil. Now, that was just a biological indicator. And chemical attributes in the blue are the few things that we look at with conventional soil testing. Well, things we've been talking about today. I'm not talking about calcium, magnesium, or sulfur. Mississippi system, we do organic matter row crops. We'll give you a calculated sulfur number based upon that organic matter content based upon Dr. Lancaster's work. Freddie Raspberry was the person who did the part of the work. Wayne Houston did part of the work for some of you older people. Both of them worked with the lab for many years. We'll give you CEC calculated. Physical components, again, there's a lot of things that we can look at. And in fact, this list comes from a review of about 4 papers on soil health assessment of things they could look at. And I quit when I got to this point coming up with a data sheet because there are so many things that we can measure now with soils. But I keep getting back that we get a wonderful snapshot of what we have just with the good old-fashioned basic fertility test. I put on our Mississippi Crop blog a couple of years ago now something about that soil pH and lime requirement are indicators of soil quality because pH is the master variable. It affects the availability of many of these chemical elements of our including things we don't test for. But we can influence them by adjusting pH. So you put all these things together, we come up with what in the middle is in the original version here by Bertan and Lyle, soil organic carbon pool, the quantity, the quality. And actually this is when the NRCS Soil Health Group talks about soil health. They're talking about this intersection we're trying to get to of physics, chemistry, and biology. We're trying to get all the parts of the symphony to come together. Back to the original theater of the soil. So, what we're trying to do is the soil itself important. Go back to Pontotoc Ridge, look at some results. Atwood and Faulkner, pH, mile apart, 2 different soils. This one started at 6.8. That one started about 5.8, 5.9. And then we stabilized out, but we have bounce. And where these low bounces come into play, again, is on the lime requirement. And that's the money part of pH. It's 2 different tests in the lab. And the money part, if you come up with consistent lime requirement, but you see, they keep coming back to an equilibrium level. And these 2 soils are very different, but in the Greek that we use in soil science to confuse other people, and this is based on Greek, these soils, starting at the back, are the same thing, have a different activity here. This is the weather regime. But where we get into, this is a siliceous active, this is a mixed semi-active. This active and semi-active is reactivity. This is the mineralogy. So these soils are close, they're the basic thing, but they're different because of where they started and how things interact. Down here in Starkville, we had the youth land judging contest on South Farm a few years ago. We dug 4 holes in 1 16-acre field. We had 1 white soil, 1 black soil, 1 red soil, 1 brown soil. These things all come together in this part of Mississippi. So, summarize my career here, and we have been looking at this for almost 6 years, aggravatingly close to 6 years. Hopefully we can get at least 71, 72 months out of it. I have been looking at tillage systems over time. I started off with a ridge till project. My first job at the University of Kentucky, looking at the effects of ridge till in some of the soils of that part of the world. Then I went on and worked on a different ridge till project at the University of Minnesota for my doctorate. And I have learned time is of essence in dealing with soils. 30 years of looking at these things, 5 years or less when you're looking at differences in things that are going to affect the soil system. You're looking at a pilot study. You're just getting started. If someone tells you you have a significant difference in tillage systems after 1 year, say no, you may have. You need more time with it because you're changing all those many factors you saw. You saw the bounce in the chemical factor. All these things have got to come together. The project I worked on in Minnesota, in ridge till was a severe potassium deficiency in corn, which did not come up in ridge till until it had been in the system for a minimum of 6 years or so. And it was serious. We're talking 30–40% yield decline or loss due to this early season potassium deficiency. And we figured out that there was an issue with the corn hybrid root architecture and the positional availability of potash in these soils. It didn't show up for 7 years into the system. And we spent a lot of time late at night trying to figure out what the heck's going on. This was so system specific. You could take a sharpshooter shovel out, go into a ridge till field that had the potassium deficiency, take the sharpshooter, stick it out, shake it for about a few times within about 3 feet. You plant corn and come back, you'd have deficiency in between where you stuck the sharpshooter. What we were doing, we were disrupting the macropores in the soil so that the roots did not use the old channel. They used up all the easily available potassium. Fun. But it takes a while to get started on these things. 5 to 10 years, you're starting to learn something. And then better than 10 years, you're starting to see the impacts change. I'll bring this up because I had it in here, I took it out. But someone who summarized this for no-till systems in another country, he said that they essentially verbalize better what I'm trying to get to, is that you have a shift in systems. And in the world of soil health, where we're looking at all these biological factors, you're developing a different suite of bugs in there to do different things. So it takes time for this to happen. So take home, soils are not easy. They're complex. There's a lot going on there. Variation exists within the calendar year, weather, the presence or absence of growing plants, and there is sampling testing variability. Question somebody might ask, do you go the exact same spot each time? In fact, one of my colleagues said, you need a GPS there. I said, I did. I have the GPS coordinate, but I don't want to go to the same spot every time because these soils move. Wayne tills them 3 or 4 or 5 times a year. So I just got to be in the neighborhood in Delta. And I'm in the neighborhood in Savannah. I just got to be close by. Sample, same time next year, the old-timey recommendations, the old men and women were right. We knew they would be, but people want evidence. And I think there's some evidence here that we do have variation through the year. It's stronger in the falls, usually, and it affects the results. And there's, of course, management factors. You have utility programs, so forth and so on. Building a road, it's generating a lot of lime dust come into play. So the bounce is expected, count for it. With that, I've been going for a while. Any questions? More questions?
Sampling variability, did you address that?
The sampling variability. I can take a sample here and go over and take a sample here. It's going to be different. It's a natural system. Didn't need a GPS unit to do that either, didn't it? Not that there's anything wrong with that. one of my major professors was at Iowa, was one of the gurus of coming up with the lag stuff. And he told me that they sampled the field out there so much he swore they took the entire 6 inches into the land, about 6 inches. I did not bring it up. This is a standard sample. See where the 6-inch samples we've been looking at, not doing some soil on this. Again, this is a typical production sample we're trying to emulate.